In this session, now we are going to see for the cooling spine numerical. So heat transfer from the cooling spine. A cooling spine of a square cross-sectional area A and length L, the conductivity K extends from a wall maintained at a temperature TW. The surface convection coefficient between the spine and the surrounding air is H. The air temperature is TA. The tip of the spine is insulated. So determine the heat conducted by the spine over here Q and the temperature of the tip. So we are going to solve for this particular numerical for the calculation of temperatures. So we need to go for this particularly a solid cross-sectional area having a square over here B by B. So B is given over here 1 by 12 feet. 1 inches, that means 1 by 12 feet. And cross-sectional area is also 1. So 1 by 144 square feet. So in that ways we need to go for the modeling of that particularly, keeping our L. Length is given over here as 2 by 3. So we are going to solve for this particular numerical. So start again. Let us say preferences thermal and just say OK. Once we are setting our preferences, now we should set for the element type. Let us say add again over here. Say OK. Add solid. In the solid we should go for the solid element type brick 8 noded 70. Rather we can say solid 70 over here. Just say 70 and say OK. We can see our solid 70 is added over here, which is specifically used for brick element type. Next is close this particularly, but whenever we are going for the solid element type, we are not supposed to go for real constant. So directly say material properties, cross check the material unit, temperature units. The temperature units are given in a Fahrenheit over here. So change it to Fahrenheit and then say OK. Once we are setting for the material properties, now we must go for the modeling. Say create. It's a 3D solid structure. So go for volume. Block by any one of the methods. So I am going to create a block by center and corner Z. We are knowing our BB are given. It's a square cross section. So B is 1 by 12 feet. So and the length is given as 2/3. So we are going to create it. B is 1 by 12. Height is also 1 by 12. And depth is also given as a 2 by 3. And then say OK. Check in isometric view. We are having that particular block with us. Now we need to go for the solution of this particular block over here. So before going for solution option, we must set meshing. Mesh tool. Now according to the given finite element representative model, we must have the 8 number of elements over here in this way. So we need to go for 8 number of divisions along Z axis and 1 number of divisions over here on the X and Y axis. So we are going to set our lines first. So for front cross section having 4 lines over here and back side. Select those and keep the number of elements over here 1 and just say OK. For the front 4 lines and back 4 lines we are setting our division 1. Now again set our lines in a size control. Set for the Z along Z axis line. Say OK. And now we are needing 8 elements along that particularly. So say 8 and then say OK. That means we are setting our lines. Now say hexa sweep. Sweep particularly this solid and just say OK. Once we are saying sweep, we can see we are having the 8 number of elements along this particular Z directional axis. And for frontal cross section, we are having only 1 element. So in that ways, we need to go for this particularly. So once our meshing is done, now we need to go for solution. But whenever we are going for that particularly, in the loadings we can see our one end which is attached to the wall is having TW temperature. So TW is maintained over here as 100 degrees Fahrenheit. So we need to apply for the 100 degrees over there. And the front face, another face is having an insulation. So we are going to see it is a static case analysis. So define our loads. Let us say apply temperature on the area. On the back area over here, we need to apply for the TW. So we are going to say temperature as 100 degrees Fahrenheit and just say OK. Once we are entering for the temperature over here, now we should come over here and say convection, because we need to insulate this particular frontal cross section. So let us say convection on the areas. Let us select that particular area where we need to apply for the insulation. Just say OK. Here whenever we are going for the insulation, keep our H value, coefficient of convection 0, and we are not supposed to enter for the fluid temperature or the bulk temperature, and just say OK. That means we are applying over here as a convection value. Now we need to apply a convection on the side faces of that particular cooling spline with respect to the surrounding over here. So H value is given as a 1 and our TA is given over here as a 0 degrees Fahrenheit. So convection on these 4 areas, select the 4 side faces over here and again one last end over here. Just say OK. Now we need to go for the H value. H is 1 and TA, atmospheric temperature, is given over here. Surrounding air temperature is 0. So let us say 1 for an H and go for bulk temperature over here as a 0 and say OK. Now we are applying for all those things. So in that cases, we need to go for the solution over here. So we must say material properties, material models, conductivity value we should enter over here. Conductivity of that particular material is given as 25. So we must go for the K value as a 25 and then set it over here in the preprocessor. Once we are setting for the material properties with respect to the given external inputs as a convection, conduction, temperature values, now we need to solve for this particular numerical for a temperature plot along that particular solid. So let us say solve this numerical for the current load step. Let us close it and say OK. So close the new pop-up window. Say general post processor, plot results, say contour plot, nodal solutions over here as a temperature plot over. So in that cases, we can see our temperature distribution along the solid from 100 to 0 with the help of convection, which is having an H value 1, and over here from this particularly. We can animate this particular over here, plot control, animate our deformed results with respect to the temperature plot over here and just say OK. So in that ways, we can see our temperature distribution, how it is affecting our solid over here. So these are the ways we need to go for the meshing of particularly the solid with respect to the definite 8 number of element, and how to apply insulation, convection for that particularly. So in this way, we are supposed to solve for solid 70 having a brick shape element type.